So 13.1, we are moving on to something that is called trig. You guys have seen a little bit, you've used a little bit of trig functions, but we're actually going to study, you've used the sine, cosine, and tangent when you're in geometry, but we're actually going to study the graphs of these guys and what kind of situations these would be in. So when we do this, we're going to look at these, make sure we understand these keywords before we move on, because those keywords are going to be used throughout this chapter. And so here we go. So it's talking about a Ferris wheel. Talks about how long it takes to go around complete rotations, 50 cents per ride. And so you should read through that. Here's a Ferris wheel, and obviously if you're talking about, so a Ferris wheel is going to be making this motion. It's going to be going into a circle. And so this is where you start at, right? You start at the ground. And as you rotate, whichever way this thing rotates, you're going above the ground. So you're going to be up from the ground. So you see the rotation. It's going up from the ground, and then it reaches its highest point, which would be right here. And then it starts traveling back down to the ground. And then that would be, once you get here, boom, hopefully, obviously, actually, we'll talk about this in just a second, but this would be when you hit this position again, you completed one rotation, and then you go back around, and so it goes back up. And so it creates this wave of an effect. But hopefully you realize right here, I don't like this graph just a little bit, because hopefully your Ferris wheel is not hitting the ground, because if you're scraping the ground, it's probably breaking, and that's not good for the Ferris wheel. So it is just a situation where they're talking, but technically, even if if it's supposed to be a couple inches off the ground, it wouldn't be touching that. The only way that could happen is maybe if the Ferris wheel is cut out a little bit and you are actually right at ground level when it hits, and so maybe they've cut a little hole in the ground so that Ferris wheel can be right at ground level. And then this graph would make sense, but they're just showing this kind of situation of a graph of where this could happen. And this is going to be a graph where we're talking about sine, cosine, or tangent. It's going to have this same kind of thing. It's going to be a wave, and we're going to talk about what this shape is called, and then we're going to get some parts for it. So that's what you need to be making sure you get from today's lesson. All right, if you look right here, if one rotation for a Ferris wheel, this is how many rotations. So you're 1/8 of the way up. You are 7.3 feet from the ground. So if we go up here, we look at this. This is, so if this is one full rotation, this is 1, 2, 3, 4, 5. So that's a fifth of the rotation. So if you're at an 1/8, it's somewhere right in here. And if you're somewhere right in here, you can see that that's 10. So 1, 2, 3, 4 is 10. So again, you're just estimating where this rotation would be, but you could see, you can look. If you notice, it says if you are halfway around, you are at 50 feet. Well, look, if I go up to here and I go to a half rotation, my peak is right there, and that's at 40. So 50 would be right there. And so that's where all they did is they just looked at this graph right here, and they estimated these spots. All right, so here's some characteristics. The graph is continuous, which means it never ever stops. So like a non-continuous graph is something that hops. It goes from here to here to here to here. There is no line that connects it. It's like that. This graph is continuous. It has all the spots in between. Meaning you could have a 7th, an 8th, and a 9th of a rotation. The graph reaches a maximum at 50 and a minimum at 0 feet. Remember, maybe we have a little hole cut out. The graph has x-intercepts at every full rotation. That means that it's going back down to the ground. The graph has a y-intercept at y equaling 0. The graph is increasing in the first half of each rotation and decreasing in the second. So it means the first half you're going up the Ferris wheel, and the second half you're going from here, you're going down back to the ground. The graph, what do you notice about the shape of the graph of each rotation? The shape is identical. So what happens, what they're saying is the first rotation, which is from here to here, is identical to the rotation from here to here, which is identical to the rotation. So this part of this graph is identical to the second rotation, because you're going up and down the same Ferris wheel. The only way that would change is if it broke, which would not be a good thing. Right here, this we need to talk about. A period function is a function whose values repeat over regular intervals. So, like this chart right here, all these same numbers right here, all these numbers would repeat again if I did another X and Y chart. It would repeat the same exact values for if I did 1 1/8, 1 1/4, 1 3/8, 1 1/2. All these values that were right here, this Y would go right with that one. This right here would go to this Y. This right here would go to this Y, because that full rotation just means that it does the interval repeats. You're going to be at that same height. At 1 1/2 rotations, you are going to be 50 feet in the air, because you go 1 rotation and a half is right here. It's the same as if I just did a half rotation. If I did a half rotation, I would be at 50 feet. If I did a 1 1/2, I would be at 50. So that's that repeating interval. And same if I did 2 1/2 or 3 3/8. It's going to be the same as the first one. And so what that is called is that when that happens is we had a period function, a periodic function. Now a period is the length of the smallest interval over the function repeats itself. So how long it takes for the function to repeat. So sometimes you have a graph like this, and we have this line right here, and then it repeats. So right here you can see from here to here, this would be a period, because then from here on the graph just repeats over and over again. From here on the graph just goes up and down, it goes up and down, and so it repeats itself. And this length from here to here is called a period. Alright, so you need to make sure you understand that. We're going to be using that later on. Alright, so what happens if this thing goes below the ground? And then this is that idea of what I just showed you, how it looks more like a wave function like we just had. And so if I was talking about a period, from here, it's not repeating to right here. So from here to here, this is the length of a period. And so you can go through and look at this. Again, they just completed the chart. Notice now it just has negative values, but if you still look, the distance between here and here, if I'm at negative 25 when I'm at the bottoms, and I go to the top is positive 25, the spread between negative 25 and 25 is still 50 feet. So the Ferris wheel is still 50 feet tall. It's just part of it is below the ground. This is now so underneath. So it's continuous, it reaches a maximum of 20 feet and a minimum of 25, has a x-intercept at every half rotation this time. The period is still 1 rotation, because after 1 rotation, the function repeats itself. But we're not always going to be on a Ferris wheel, so please be careful with that. All right, standard position. Standard position is when the vertex is at the origin. Remember, the origin is right here on an X and a Y chart. And one of the angles is the x-axis. So this right here is one of the angles. If I have any angle coming off of that, okay, that is going to be called in standard position. The initial ray is the one that is on the x-axis. This one is called the terminal ray. So those are the things they're going through. All right, so use a straight edge. All right, so you can follow these steps, and they're just lining it up. So they drew this. So if you notice, this x-axis right here is identical to this x-axis right here. They do a 45-degree angle try to make sure you use the compass to make sure that's a 45-degree angle. Then they do a straight edge to match where this hits on the circle, and they draw it straight over and put it right there. And if you notice, it's on the 45 because this down here represents the angle. So this is 45. That's why up at 45 they went to this height. And they're going to keep doing that for all of these down here. And they're going to continue that graph. And what they do is you have to turn this sideways. They make this graph from doing that. These are the points that you should have plotted on your graph from what you did. So all they did is they matched, this is the 91 right here, and all they did is they drew a straight edge that connected it to right there. So if we determine the period, the graph represents, repeats every 360 degrees, so the period is 360 degrees. Every 360 degrees, the Ferris wheel has made another completion. And so now we're talking about, before, just to make sure you understand this, our x-axis on this one has changed. Our x-axis is now in degrees, whereas when I go up to this top one, my x-axis is in rotations. See, we changed the unit. Up here, this is the x-axis is number of rotations. So it's one rotation is like right here. Whereas down here, when I do my measurements, I've now measured in something else, and what the measurement is called is in degrees. Right here, if you see it, you can read that on the side. It says it's talking about measured in degrees. So the maximum value is 25 and negative 25. At certain angles, a writer is the highest and lowest. List 4. So this is 90 degrees, 480, 810, 1170, because that's just, this is just now, okay, so at 90 degrees, I'm at my highest. Well, now I rotate 360, then I go up another 90, so that's that 450 degree mark, because the person rotated, sorry, they started here, they went one time, which is 360, plus another 90 is at 450. Then the next one right here, how did they get that number? They went one rotation, two rotations, and then halfway back up. So that would be 360, 360, and then a 90, and then again, they would be back up at the top. That's how they're getting all these numbers right here. So list where the lowest point, well, that would be, now they're going to be at the lowest point, right? So they say 270. Let me see this. Oh, on this one. We're talking about on this graph. So 270, they're at their lowest, and then 630, and you can see that that's because this is a map of the one that's underground. That's the Ferris wheel. This would be my 0 would be my ground. This is 25. This is negative 25 for height. So that's where they're getting all those answers from. All right. So amplitude is the period of a period function is 1/2 of the absolute value of the difference between a minimum and the maximum value of the function. So basically, it's the distance from the peak all the way to this midline. And this midline is a reference line whose equation is the average of the minimums and maximums. So it goes right in between the peaks and the valley. The midline goes right in the middle, and the amplitude is a measurement from the peak to the midline. You could also do this. Now, they say absolute value because this value right here is going to be positive. This value right here is going to be negative. I don't care about it being positive or negative. I want just what's the distance from here to here. And when we talk about distance, it's positive. So that's what they're referring to. All right, so that should get us through what we need to do. Like I said, we'll talk more about it in class tomorrow. Just get a basic understanding of this. Have a good night, guys.